Hello and welcome. We will talk about the first Mars colonists shouldn't be human. The plan to purposefully contaminate the red planet. The Cassini pictures are some of the most beautiful taken by mankind. In its many years spent circling and photographing Saturn, the spacecraft at the heart of the Cassini mission gifted humanity exemplary images of beauty, detailing the swath of storm at the planet's north pole and the moon suspended in their faithful orbits. One introspective image shows the fine, soft body of Earth as seen from the dark side of Saturn. Our home hovers in the distance. A milky white mote appearing rather unremarkable amongst all the other stars and cosmic bodies that too are stitched and sailing on their black boundless sea. Altogether the craft managed to take over 400,000 images in its almost 300 Saturnian orbits. But there was one particular discovery Cassini made which cost the craft its life. The spacecraft could have been put into orbit around Saturn. There, its instruments would have allowed it to continue making important observations and sending data back to Earth. Instead, the team at NASA decided to purposefully maneuver Cassini into Saturn's hostile atmosphere where the craft would plummet, malfunctioning and melting into an unrecognizable mass. What had Cassini discovered that marked it for death? Enceladus, one of Saturn's 53 confirmed moons. Cassini reported that Enceladus has a fascinating landscape of saltwater oceans under its ice and erupting plumes. Present are almost all the chemical ingredients required by living organisms, while hydrothermal vents are thought to provide the moon's ocean with a warm, wide array of minerals. These are not unlike the conditions thought to preface life's beginning on Earth. If Cassini had been allowed to remain in Saturn's orbit, there was a chance the craft could have someday collided with Enceladus's surface, contaminating the landscape with our microbes and ruining our chance to study whether or not the moon had native life of its own. Spacecraft do undergo intense sterilization, but it's impossible to kill every organism before departure. Bacteria and fungi survive on the International Space Station. Hardy tardigrades endure even the unwelcoming vacuum of space. The rovers sent to explore the dusty Martian surface were thoroughly cleaned, but at least some microbes will have undoubtedly traveled to and touched down on the surface of Mars. An international treaty states that spacecraft must be sterilized to the best of our abilities in order to avoid contaminating any new worlds. These places should be studied in their most natural, pristine form. The argument is a sound one. But humanity is soon approaching a crossroads when this no longer needs to be true. We should purposefully introduce Earth microbes to Mars. That's the proposition put forth by a recent paper in the FEMS Microbiology Ecology journal. The logic is this: in the coming decade, NASA and companies like SpaceX plan on sending people to Mars. We have long had ambitions of transforming the planet into a home away from home. In our grandest dreams we even consider terraforming Mars and making it as Earth-like as possible. Our reasons for doing this vary. Some say it's good to have somewhere to go in case of a disaster, some like the idea of becoming a two-planet species, some consider it a fundamental stepping stone for civilization's growth. Whatever the reasons are, we want to transform Mars into a place where we can enjoy a life similar to the one we have here. Few people want to live in confined domes all their days, decked in heavy spacesuits whenever they want to trek the valleys of the red planet. We need something more free, more familiar. Once we have committed to living on Mars, the first colonists should not be people. They should be microbes. It wouldn't be contamination, but rather a careful, purposeful introduction of beneficial organisms to the planet. Cyanobacteria are what made the environment on Earth suitable for more complex life forms. They took the early clouds of carbon dioxide and recycled them into oxygen. Along with fungi, algae, and protozoans, these organisms have been the biggest single factors in creating the environment we enjoy today. The hope is that they'll do the same on Mars. Not only that, but because bacteria are part of the carbon and nitrogen fixing process that makes for rich soil, they would be the basis for a new food chain. These agricultural benefits enable a sustainable food supply. Fresh fruits and vegetables in an alien garden would be a dream to the local inhabitants. However, the microorganisms must first survive dozens of hostile elements regarding space travel and arrival. The proposition is a frightening one. It's especially so at a time like this when we understand how dangerous microorganisms can be. How would they evolve in space? Gene transfers cause organism evolution, but knowing when this will happen or what it will mean for us is completely unpredictable. Nor can it be prevented. This is why scientists emphasize the fact that we'll have to thoroughly study and understand these organisms before we send them over. Considering there are an estimated 1 trillion microbial species on Earth, it'll take a lot of effort and investment to say the least. The large amount of money we use on sterilization each year would be better spent on differentiating between beneficial and harmful microbes. Removing only the harmful variations would mean savings of millions of dollars for each space project. In some cases, sterilization has cost up to $300 million that could have been spent on scientific experiments and development. Besides sending only beneficial bacteria to the Martian surface, new technology will also track and monitor it. It'll be fascinating to see the true gritty nature of life, how they'll struggle to survive the increased radiation, the suffocating atmosphere with less than 1% oxygen, low pressures, extreme temperatures, a lack of easily accessible water. And if they do survive all these challenges, how will it change them? In theory, our advancements in technology mean that if our organisms did mix with any pre-existing life on Mars, we'd still be able to tell the two apart. This is thanks to controversial procedures like DNA sequencing and gene manipulation, which have given us a better view into the fundamental structure of life. The study assures us that the mixing of Earth and Mars life forms is unlikely. There is little chance we'd mistake one for the other. And herein lies another point: hundreds of pounds of Martian crust has been ejected into space and landed on Earth in the form of meteorites. Estimates say a similar amount of Earth's soil lands on Mars in much the same fashion. Cross-contamination then is already a naturally occurring phenomenon, making sterilization seem pointless in this context. Yet there remains an unsettling truth to the idea of microbe introduction. As much as we can monitor and handpick these organisms, as with any life forms, they will never be fully under our control. It's a risk we need to consider in readying our first human missions to Mars. We cannot sterilize people the way we sterilize equipment. As the researchers pointed out, there is no way to separate a person from their microbiome. The colonists will come with food and life-sustaining tools. As warm silken days come and go, people will eat, explore, and produce waste in the process. But the confrontation occurs much sooner than that. The moment we step foot on Mars will be a collision between Earth life and the harsh Martian elements. If there are native organisms on the New World, then it will also be a collision between life forms. But Mars doesn't have to be so foreign and so rough. The right microbes can transform the new planet into a new home for our arrival. All they need is the chance to go ahead. Thanks for watching. Please subscribe my channel. Please like this video. Please write a comment. Goodbye until new video.